All right, so number 20, we are back to graphing, and the directions here are graph the linear inequality in two variables, and they provide a nice little hint for us, and they say do not forget to shade. All right, so we are given an inequality, x plus y is less than or equal to 7. And we know right away that we are going to be shading because we don't have simply an equal sign. When we have an inequality and we're asked to graph, we know right away that we're going to be shading on one side of the line or another, depending on our test point. So don't let this inequality scare you. Go ahead and treat this given inequality here just like you would a regular equation. So pretend that for the purposes of simply putting the line on the graph that this is an equal sign. So we're going to have x plus y equals 7. All right, so how would we graph this? Well, we can do one of two things. We can either choose x and y, or find our x and y intercepts, or we can choose any 2 points, or we can go ahead and just solve for y equals mx plus b. And that's what I'm going to go ahead and do. So we'll subtract x from both sides, and we get y equals negative x plus 7. And when it's in this form, we know that y equals mx plus b. B is going to be our y-intercept, right, where it's 0, comma b, and then m is our slope. So this makes it nice and easy to graph this first point here. So we're going to go to 7 on our y-intercept, plot that first point, and from that first point, we're going to use our slope, which in this case is negative 1, and that is going to help us find our next point. So if our slope is negative 1, that means we're going to go down 1 and over 1. And then we could keep repeating that process an infinite number of times to get additional points. But remember, we only need 2 points to graph a line. All right, so we know that this is going to be the graph of our inequality. And the one thing that we do need to keep in mind is with an inequality, our line, the line of our graph, is going to be either dotted or solid depending on what this inequality is. And so when it's less than or equal to or greater than or equal to, that is going to be a solid line. And if it's simply less than or greater than, that's going to be a dotted line. And so in this case, we have that equal sign, we have that less than or equal to, and so we know that this line is going to be solid. All right. And now the last step that we're going to do with an inequality is we need to determine on which side of this line, above this line or below this line, are we going to shade. All right, and so to do that, you'll recall that we're going to use what's called a test point. And all a test point does for us is helps us to determine where we're going to shade. And the easiest test point to use is 0, 0, the origin, provided that your line, your graph, does not go through 0, 0. So you can choose any point in the world to use as a test point so long as that point does not lie on the graph itself. And we can clearly see that 0, 0 does not, in fact, lie on this graph. So let's go ahead and choose 0, 0 as our test point. All right, so we're going to test 0, 0. And all that means is once we've chosen our test point, we're going to take that point and plug it back into our original inequality and see if we get a true or false statement. And let's go ahead and do that, and we'll explain why in just a second, depending on what we get here. So if we're plugging in 0, 0 into our original inequality, let's see what happens. So x plus y is less than or equal to 7. So if we're plugging in x and y, we have 0 plus 0 is less than or equal to 7. Well, 0 plus 0 is just 0, is less than or equal to 7. Is this a true statement? Is 0 less than or equal to 7? Well, yes, of course, that is a true statement. 0 is less than or equal to 7. And since the point we chose to test was below this line, that means any point below the line will also give us a true statement, and we want to shade where the answers or where the points make the inequality true. All right, and so because our test point of 0, 0, in fact, when we plugged it in, made our inequality true, we're going to shade below the line because that means any point below our graph here will also give us a true statement. If we were to choose a point above this line, so let's say maybe 8, 8, right here, if we were to plug that into our inequality in test, we would get a false statement. So let's go ahead and actually do that. Let's just prove this. So let's say, and I'll go ahead and do this in a different color here. So we're testing this point here, 8, 8. So test point 8, 8. Plug that 8, 8 into our inequality and see what happens. So that means we're going to get 8 plus 8 is less than or equal to 7. Well, what is 8 plus 8? 8 plus 8 is 16 is less than or equal to 7. Is this a true statement? Is 16 less than or equal to 7? No, that's a false statement. And so in this case, because our test point was above the line and we got a false statement, that means any point above this line will also give us a false statement. And so we know we're not shading above because we only shade where the points make the inequality true. And so if we got a false statement above the line, we can automatically shade below the line. All right, but you don't have to test both sides of the line. As soon as you test one side and you get an answer, you know right away which side of the line to be shading on. I just wanted to show you that because we definitively tested our 0, 0, our origin, and got a true statement, I wanted to show you that we would definitely get a false statement if we chose a point above the line. All right, so again, don't let this inequality scare you. All you're going to do is pretend that this inequality is an equal sign simply for the purposes of graphing your line, not forgetting, of course, to either use a solid or dotted depending on what that inequality is. And once you have your line graphed on the plane, your rectangular coordinate plane here, go ahead and choose a test point, any point you can choose, so long as that point is not on the line, not on the graph itself. And then depending on whether or not you get a true or false statement will tell you where to shade, either above or below that line.